What are the best Ethereum wallets out there? How do Ethereum wallets work, and what's their purpose? What is gas, and how is it calculated? Well, stick around. In this episode of Ethereum Whiteboard Tuesday, we'll answer these questions and more. Hi, I'm Nate Martin from 99 Bitcoins, and today we're going to talk about Ethereum wallets, those pieces of software or hardware that allow us to interact with the Ethereum network. At its core, an Ethereum wallet, also known as a client, holds your private key, the secret password that gives you control over your coins. It also supplies you with a public Ethereum address, which people can use to send you Ethereum's currency, known as Ether. This is almost as far as Bitcoin and Ethereum go in terms of similarities. Many non-technical users think of Ether as a currency in the same sense they view Bitcoin. They buy Ether in hopes that its price will rise. They pay for stuff with Ether and more. However, Ether wasn't designed for the same purpose as Bitcoin. If you've watched our previous video, What is Ethereum? And if you didn't, you should, you know that Ethereum is a network of independent computers working together as one supercomputer. This supercomputer executes pieces of code known as contracts or smart contracts. Interacting with contracts requires more complex communication than to just send X amount of money from Y to Z like Bitcoin does. Ethereum wallets are the tool we use for this communication. So, in order to truly understand Ethereum wallets, we need to first understand how Ethereum is built. In Ethereum, there are two types of accounts. The most basic type of account in Ethereum is called an EOA, or externally owned account. Similar to how a Bitcoin wallet operates, EOAs have an Ethereum address that is controlled by a private key. A person can open as many EOAs as he likes. In addition to sending and receiving Ether, EOAs have the ability to create contracts and to trigger them. The second type of account is the contract account. These are accounts that have code associated with them. Every contract deployed to the Ethereum network has its own account, which includes a unique Ethereum address. However, unlike an external account, a contract account doesn't have a private key that controls it. So, how is a contract account controlled? Well, the code that defines the contract includes a set of predefined triggers which control the account. In other words, the conditions to control how the contract operates are hard-coded from the get-go. Similar to EOAs, contract accounts can receive Ether and, if triggered, send Ether or even create additional contract accounts. It's important to note that contracts can't be changed once they've been launched, so the author must be very thorough in drafting the conditions for each trigger. EOAs can interact with other EOAs and with contracts through messages. These messages are wrapped inside transactions which are paid for in Ether. So while in Bitcoin transactions are used only to transfer value, Ethereum transactions are used for a variety of reasons. First, transactions are used for the transfer of value. And this is the simplest form of transaction, meaning to send Ether between accounts. You can also use transactions to create a new smart contract. Creating a new contract is done by sending a transaction that includes the contract's code. And finally, transactions can be used to trigger a contract. For example, when you send money to an ICO's contract account address, you're actually activating a contract that sends you tokens in return. Now that you understand how Ethereum is built and that transactions are in fact used to help accounts talk to each other, we can move on to Ethereum wallets. Some Ethereum wallets will only allow you to transfer value or send Ether between accounts. Other wallets will allow you to also deploy or trigger a contract. These wallets are known as smart contract wallets. Similar to Bitcoin, wallets are sometimes referred to as clients or nodes, and there are two types of clients: full clients and light clients. A full node is a computer that holds the entire Ethereum blockchain history since its inception until this day. Running a full node has disadvantages like increased memory and computer usage. However, it allows you to verify transactions on the Ethereum blockchain without needing to trust anyone's word for it. Full nodes are an integral part of the Ethereum network, as they are the muscles of the network that help execute contracts in a decentralized manner. Each node that receives a new block of transactions also executes the code inside these transactions. There are different programs to help you run an Ethereum full node. We won't discuss all of them. However, we will talk about the most common clients. The first one is Geth, short for Go Ethereum. Developed by the Ethereum Foundation, a nonprofit organization established to develop the code and community for Ethereum, Geth is the most popular and widely used program. The second is Mist. Since Geth is a tool made for developers, Mist was created in order to allow non-technical users to interact with it. So, while technically you're using Geth, Mist provides you with an easy user interface to talk to it. And finally, Parity, which is a private company based in London whose mission is to enable businesses and organizations to capitalize on blockchain technology. They developed software to run full nodes for Ethereum and are considered the second most popular full client. Just for reference, at the time of releasing this video, there are 9,713 nodes running Geth and 4,069 nodes running Parity. All full nodes are smart contract wallets, meaning they can deploy smart contracts to the Ethereum network. If you don't want to run a full node, you can use a light node. Light nodes, similar to Bitcoin's SPV wallets, are programs that rely on third-party full nodes in order to get information when needed, rather than holding a full copy of the blockchain. This means they require less space and can operate on devices with limited space, such as mobile phones. Being the second largest currency by market cap in the crypto market, Ether has caught the eye of day-to-day users. These users will usually use light nodes as their wallet since it's easier to install and operate. If you don't intend to write smart contracts anytime soon, you can use any of the light wallets listed in our website for the most user-friendly experience. Let's talk a little bit about Ethereum hardware wallets. If you're serious about security, I suggest storing your Ether on a hardware wallet. While being the most secure way to store your coins, hardware wallets cost money. Also, hardware wallets are not smart contract wallets by design. They can only send and receive Ether and ERC20 tokens. Now let's move on to transaction fees and gas. Trust me, you'll understand in a few minutes. While Bitcoin can be divided into 100 million units, with the smallest unit called a Satoshi, Ether can be divided into 1 quintillion units. That's a 1 with 18 zeros after it, with the smallest one being called Wei. Wei is named after Wei Dai, a cryptography activist who is known for supporting widespread use of strong cryptography and privacy-oriented technologies. Fees for transactions are currently calculated in gigawei, so 1 quintillion Wei equals 1 Ether, and 1 billion Wei equals 1 gigawei. There are also other names for different amounts of Wei, all named after famous cryptographers, as shown in this table. In Bitcoin, to send a transaction, we need to add a miner's fee to it. This way, we incentivize the miners to include it in a block. In Ethereum, we must keep miners incentivized as well for their contribution of computing power to the Ethereum supercomputer. Just like a car, the Ethereum network runs on gas. Each line of code that needs to be executed by the network will take up a certain amount of gas. Run out of gas and your code stops running. You specify how much gas you're going to use up front, and you can't refuel on the way. If your contract runs out of gas because it's written inefficiently or you miscalculated, it will just stop in the middle of the road. This system motivates smart contract programmers to keep their code lean and optimized, since gas costs money, as we will soon learn. The gas you pay goes to the miners, as they are the ones investing computing power in order to update the ledger of Ethereum transactions, similar to what goes on in Bitcoin. Keep in mind that gas isn't something you can own. It's just a unit of account to measure how much work is needed to run a line of code. Think of it as the equivalent of hours of labor. Gas is paid in Ether. Now, I know what you're thinking. Why not just price execution of smart contracts in Ether? Why do we need another virtual currency? Well, Ether's price is constantly changing, and if we priced contracts in Ether, the price would be different each time we calculated it due to the fluctuating exchange rate. Imagine we'd price painting our house at 2 Ether. Sometimes it would cost us $1,000 and other times $2,000. With gas, running the same contract several times will always bring back a fixed amount of gas to be paid, just like painting the same house takes the same amount of hours every time. So how much gas do you need to run a line of code? Easy. There's a predefined amount for each action you want to run in your code. For example, sending Ether from one address to the other requires 21,000 gas units. Now comes the tricky part. how much do you actually pay for a unit of gas? The price of one gas unit changes all the time, depending on how crowded the network is. The same way an hour of labor would cost more if many people are looking for employees, the gas price rises when the network is crowded. The standard gas price is around 20 gigaway. You can consider this the average salary on the market for an hour of labor. If the Ethereum network is very busy and you want your contract to get priority in execution over other contracts, you may overbid the gas price so that miners will have an incentive to include your contract in the next block. You're basically saying, I'm willing to increase your pay per unit of labor so you'll give my work priority. This is similar to how Bitcoin transaction fees rise when the network is crowded. When you send a transaction in Ether, you also need to specify a gas limit, meaning how much gas you're willing to use at maximum for running your lines of code. This is done in order to protect you from depleting your funds in case your code has an error and runs endlessly or inefficiently. You pay the full amount for your gas limit up front, and there's no option for refueling. This can cause certain things to go wrong. For example, if you overpaid and your contract ended up using less gas, you'll get refunded for the gas not used. However, if an operation ran out of gas midway, it will halt, just like your car, and no Ether will be returned to you, just like a gas station doesn't refund you even if you didn't have enough gas to get to where you wanted to go. This can happen if, for example, your contract needs to do some reoccurring function that keeps on consuming gas and finally runs out. If you don't include enough gas units for running your code, no miner will pick up your transaction since it doesn't have enough gas from the get-go. And finally, if you choose enough units of gas but pay very little for each unit, it may take a lot of time for your transaction to go through since miners will prioritize higher paying transactions. To conclude, an Ethereum fees are a general term that refers to the gas used multiplied by the gas price you were willing to pay. In other words, the hours of labor worked times the wage per hour. The higher you're willing to pay per gas unit, the more miners will compete for running your code, and the faster your transaction will be included in the blockchain. That's it for today's video. Hopefully, by now you have a better understanding of Ethereum's wallets, Ethereum accounts, gas, transaction fees, and also the various wallets you can choose from. As you probably noticed, Ethereum is a lot more complicated than Bitcoin, mainly because it's intended on executing much more complex functions than just sending money from A to B. Don't worry, it gets worse. But we'll talk you through it, as always, in upcoming videos. You may still have some questions. If so, just leave them in the comments section below. And if you're watching this video on YouTube and enjoy what you've seen, don't forget to hit the like button. Then make sure to subscribe to the channel and click that bell so you'll be notified as soon as we post new episodes. Thanks for joining me here at the whiteboard. For 99bitcoins.com, I'm Nate Martin, and I'll see you in a bit.